There's a lot of buzzwords out there when it comes to artificial intelligence because it's a, hot topic in the media more than anything. But sometimes you need to demystify a whole bunch of stuff before you can get started. And that's exactly what we're doing today on the Data Radio Show. Hello there. In this week's episode of the Data Radio Show, I'm going to sit down and chat to AI expert Ole Bause. He's going to demystify some of those terms and layers behind AI that maybe you don't necessarily know 100% of, especially if you're starting out in the industry. We're going to take a look at exactly how things like neural networks work and the different types of artificial intelligence that are out there. And we're going to take a look at how it works in building tools like Flow.BI, which is a tool that's been designed by Scale3 out of Germany to help people build data architecture. But before we get into this week's interview, don't forget to hit that like button, share the video, subscribe to the channel. And if you're listening to this on a podcast, do all of those things as well, but in the podcast version of it, depending on the platform that you're listening to. Anyway, let's jump over. Let's have a catch up with Ole and learn a little bit more about artificial intelligence. Hello there. Welcome to another episode of the Data Radio Show. Joining me this week, I've got Ole Bause from Germany. I'm guessing it's like Germany. It's not like a part of Germany that's not really Germany, if that makes sense. Like one of the little outlying areas that are like not German, full on German.
Yeah.
Okay. You can tell I come from the complete opposite end of the world. So I don't know my borders very well with these things. Although I did find out, weird little side note for you, because my ancestors are from Germany. We were told they were from Germany. Turns out they're from Poland. Which gets things a little confusing sometimes. It's very strange. Anyway, Ole, AI, you are a bit of an expert on this field, and I wanted to have a chat to you because, one, I want to learn about Flow.BI, that I understand sort of getting up and running, and I've had a look at some of the stuff that's come through on there. A little confused by the website, not sure why there's a school of fish on there, but it looks like a really interesting tool for helping to build Data Vault. And I know AI is getting a lot of talk at the moment around how it can be used for things like data warehousing. But I had a look over one of your presentations, and there's a really interesting sort of basic breakdown of some of the sort of buzzwords and terms that we get a lot. I'm hoping you can sort of run me through it a little bit so that for people who might just be coming in, who haven't really had a huge amount of experience in this field, they get a better understanding of what those terms actually mean and where maybe a little bit where they came from. Like I'm really curious about neural pathways and why they work the way that they work in AI and sort of the relation back to the human brain. So I guess, the first big question is, what is AI?
Yes. I mean,
an easy one to start with.
Yeah. I mean, AI, and I think everyone knows what these two letters mean. So it means artificial intelligence. But what is behind is of course a bit more difficult, and also the understanding of what AI means has also shifted a bit from time to time. So while in like 20 or 30 years ago, when people were talking about AI, they were meaning the other thing of what is AI was more around like some general intelligent computer that is able to do any task that a human can do. Nowadays, it's more like an understanding of that AI is a technique or a set of techniques that enables computers to mimic specific human behavior. So there are a lot of different areas where this can fit, but of course, especially, it's all around data, and artificial intelligence itself, of course, also has a lot of different subsets, as I said. So especially machine learning, also deep learning, and also another word that just came up the last years, like generative AI. And maybe to make it short, to give a short overview of all these buzzwords in the end. So machine learning itself, it uses just mostly statistical methods to enable computers to learn from the data and improve. But there's no no real intelligence behind. It's just statistical methods. And when it comes to deep learning, we get these neural networks, these mystical neural networks, where everyone says it's like a black box. You don't know what's happening inside, but in the end, you know what's happening inside. But how these neural networks are deciding is a bit difficult to explain. But yeah, it is able to learn very decent stuff from the data and can mimic human behavior way better. And then we have generative AI, which is mostly part of deep learning and is used to generate new content. It can be text, it can be images, it can be code, and it can also be like what the data modeler is doing, like what Flow.BI is trying to do.
That was a really good in-depth explanation as well. Like that was really handy. It feels to me kind of like there's levels of artificial intelligence, the way that you've explained it. Machine learning, sort of your high level stuff, and something like generative AI is down a few levels, and it sort of incorporates other elements. So it's one of those things that people kind of know the buzzwords for, but don't know how it all fits into the big picture.
Yeah.
One of the things I've come across with generative AI, and you might be able to answer this one for me, you might not, really bad at maths. And I'm wondering if there's a reason for that.
Sorry, can you repeat the last?
So one of the things I've come across with generative AI seems to be really bad at mathematics problems. Um,
Okay. Mm.
and it's one of those things. I've seen people on Twitter, for example, who are like, well, this can't be the future of everything because I can't do a basic maths problem. Can you explain why that is?
Yes, there's an actual reason for that. So for AI is especially very basic mathematical stuff like simple additions or subtractions are even not easy for an AI. And the reason is that an AI doesn't think in numbers like we calculate. So in the end, all an AI knows is stored in very big arrays and matrices, and there are no round numbers. So you never have round numbers in these big matrices, and therefore it's really hard for an AI to understand that these clear separations between numbers, that there's a 1 and a 2 and 1 and 2 is 3. That is very difficult for them to understand. I mean, bigger AI models are going, researchers have found a good way to go around that and to make AI actually very good in mathematical stuff. And that is that the AI can define formulas and calculations, but it can't calculate it. So it just defines the calculations and then uses, like programs this calculation in program code, and then this calculates it, and then So nowadays AI has got way more better in calculating mathematical expressions. Yeah, but just with this wound up.
Nice. Um, Tell me a little bit about deep learning. How do neural networks work? I mean, I imagine that the term itself comes from just how a brain works. Synapses firing, connection points in the brain. It must be a digital version of this.
So I mean, the name deep learning and especially neural networks comes from the idea that it's a bit like a brain. So in a brain we have neurons, and in a neural network we also have neurons, um, and it's also composed of interconnected neurons. But they are of course way more organized than in a real brain, and they work of course very different compared to a real brain. But this comparison to a brain is matches very good. So we have these neurons, and every neuron has a specific value and function. For example, also in value and function, and stores like a super small information. And one neuron alone doesn't know anything and is completely useless. But if they are organized in layers, you can have all these complex logic we have today. So these layers often consist of the first layer is often is in general the input layer, where just the data gets into the neural network, and then you mostly have a lot of hidden layers, so-called hidden layers, um, where you have in nowadays models billions of trillions, even trillions of neurons that are all interconnected. And then in the end, you have an output layer. Yeah, maybe you have like a model that detects if an image is showing a dog or a cat. Then in the output layer, you have maybe only two neurons that say, if one neuron activates, it says, okay, this is a cat. If the other neuron activates, okay, this is a dog. And but the whole magic is, of course, in these big hidden layers, where everything is stored and everything is trained. Yeah, so every neuron has a weight, a specific value, as I said at the beginning, and in the training, all these values are trained and optimized with the specific weights to learn all the complex patterns in the training data.
So the cat versus dog one seems really simple in terms of how it operates for a human. We can look at that and go, that's a cat, that's a dog. For a digital neural network, is that then breaking it down, going, this is the face shape, this is the whisker length that you'd find on a cat, but not a dog. And it narrows down its choices by basically eliminating or matching data?
I mean, so you can imagine it a bit in a way, but it's not detecting an ear or a nose and says, oh yeah, that's a nose and it looks like a dog nose. It's more like it detects specific shapes, and this can also be very, very hidden shapes that are not visible to our eyes or to the image, because in the end, neural network only works on the data and not on the image. So every pixel, for example, has three different values for red, blue, and green. And it only uses these values, but actually you can show that it detects specific shapes and a combination of specific shapes and contours. And if that's the case, it can learn that something is a dog or a cat, but of course it needs to know this image is a dog to learn it. A lot of dog images that are classified as dog images and cat images, and then it can learn it. Yeah.
I read somewhere, I think it might have been a Chinese AI model, where they were using it to originally try and find things like moles, cancerous moles on people's faces. And it ended up being so accurate that it could pick up cancer cells from a CT scan, like it recognized the same kind of data inputs. Are there a lot of surprising sort of opportunities for AI in that respect, things that humans might not necessarily have seen a connection to that have been discovered?
Yeah, I mean, that's what's already happening today with a lot of different X-rays that, many X-ray images are already, pre-sorted from AI models that, yeah, were able to learn to somehow identify, for example, cancer. Um, it works very similar to the cats and dogs example, but only just about, is there, for example, a possibility for cancer or not? And in the end, they are trained in a way that are very, very sensible. So they try to make the uh, rate of not detecting an X-ray image that actually has cancer very, 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 very low, almost zero. So it still has to be and a doctor have to look at it afterwards. But yeah, it works very well to pre-sort all the stuff.
Okay. When you're building a neural network and you're putting these things together, how do you build the weights of the input? So it goes, this much information is this important, that much information is that important. Is there a way of doing that while you're building this, or is this something that machine learning basically does for itself now?
Yes, in general, the AI learns it by itself. So it works like I explained it already, that we have a lot of layers with billions of neurons, and they are all initialized with a random weight, with a random number in the end. And then when the training starts, there's a process so-called backpropagation. So, and this is the actual magic of every neural network in the end. And it happens in a way that you put in the input data, it runs through the neural network, you get an output, and then this output is classified in the end. So it is the AI can classify by itself, is this a good output or not?
Mm-hmm.
And after that, it can optimize all the weights backwards to improve this output. So the only important thing is that the AI in the training process has to know, or the AI has to know what is correct and what not. And then it learns it by itself. Of course, there are some other techniques in AI, like also reinforcement learning, where also the AI learns it by itself. And there are also techniques where some user input is used to improve it. That's also, for example, a way how ChatGPT improved it to learn a bit better the contact with the chat functionality in the end. How to talk with people. This was trained also ethical consideration, like when it should not give an answer. This was trained, for example, based on user input, but the general AI model was completely trained on the data based on this backpropagation process.
I imagine because that large language models obviously involve language. How difficult then is it, as somebody who grew up in an English-speaking country where English is primarily the language I know, how difficult is it to build something like this that works in something like German or French or American English?
I mean, I would say the language doesn't really matter, because in the end you need just a lot of training data, and if it's in a specific language like English, then the AI model of course learns English,
Mm-hmm.
and if it's in German, it learns German. Um, but what you definitely need is, of course, a lot of specific knowledge into large language models and generative AI to be able to create and train your own large language model, and a lot of resources. So a lot
Mm-hmm.
of computer resources. Especially these big large language models are really, really resource intensive in the training. And one training process iteration costs like millions of dollars. So
Mm-hmm.
at least for example, for ChatGPT, there are some estimations how much the training was actually costing. But of course, it's possible to do it with less resources. But nowadays, people normally, if they want to train their own model for a specific purpose, they take some open source base models. So there are a lot of base models outside that are open source.
Mm-hmm.
For example, Meta has also published their big large language model called Llama. They have published it open source, and then you can take it and you can just fine tune it, which means if you imagine all these layers with these hidden neurons, you just take the last ones where the output is decided, and you just train this small part, which needs way less resources, and then you can fine tune a general purpose model to train it for a specific task, like to be able to decide specific medical decisions and act like a doctor, for example, or to do some other stuff.
Does because it's learning at the same time as well, does it have issues around almost intangible concepts? Like it might be able to recognize, say, physical signs of love, heart palpitations or pupils dilating, stuff like that. If you would describe, if it was to try and describe something like an emotion, would that
Mhm.
throw a spanner in the wrench because it doesn't have firsthand experience with being able to identify things like that?
Yeah,
Can
so I mean,
robots love?
Yeah, I mean, it's clear that this AI doesn't have any real feelings,
Hmm.
but because it is trained on so much content, and of course also on it is also trained on books and also on love books, for example,
Hmm.
where maybe this emotion is explained very detailed, it can also imitate it relatively good. So I've never tried it out, but I would definitely expect that many large language models are able to yeah, mimic like emotions in yeah, in text, of course, only um, relatively good. Yeah, I mean, large language models are also very good in writing poems, for example,
Hmm.
and a good poem doesn't work without any emotions, right? So yes, but it still doesn't have a real understanding of emotions, of course. Yeah, in the end, it's just numbers in the background going back and forth, and yeah.
Man, I feel like these were conversations they were having on Star Trek around the character data. Whenever he'd do something like write a book or play an instrument, it's like, yeah, you're repeating what somebody else has done. Doesn't
Yes.
feel like there's any originality to it. Hmm. That's all right. That's fine. How then do we use something like artificial intelligence in its really broad sense to build data warehousing, data modeling?
Yeah, I mean, in the end, we can try to train any AI model to output whatever we want, right?
Hmm.
And we already have AI models that can are really good in writing text. We already have AI models that are really good in generating images or even videos based on AI. But there was not yet any AI that is able to generate yeah, models based on data, yeah, we can use for our data warehouse. But yeah, this is exactly where Flow.BI comes in place, and Flow.BI is the currently the only one that is yeah, providing a tool we have a generative AI in the background that looks at the source data and tries to generate a valid data vault model or any other model yeah, for these data to use it on the database.
For something like Flow BI, how nuanced is the detail? Because obviously everybody's data needs is different. Everyone's warehousing needs are going to be different. Is it looking at everything down to a cell on cell level, or is it looking sort of a broad picture going, this is a bank, so this might be the best model for you? How detailed can we go?
Yeah, so right now it's completely data driven. So
Hmm.
it not only it looks at mostly at two different things. So first one is metadata. So
Hmm.
like what are the names of the columns, what are the data types, and so on. And second, also on the actual data. For example, sometimes you can't really identify, for example, based on a column name, is there personal identifiable information in it or not? And this is important to know if you, for example, want to split your data into two satellites, one with privacy related data and one without. Yeah, so in general, it looks at, especially at the data, it's very data driven and looks at these two things.
That does raise a really interesting question for me. If AI is doing that, does it then give you, as a warehouse builder, a chance to sort of step back and not be interacting directly with personal data? Because obviously that's a big deal everywhere in the world. There's concerns from all sorts of corners about um, people's storage of personal data, what it gets used for, and how it's accessed. And being in Europe, you have the strictest rules in the world around it. Does having an AI tool that helps you build your warehouse give you basically an extra step of protection for yourself?
Yes, I mean, regarding yeah, privacy related stuff, it's of course a bit difficult. But I mean, in the end, we have to see how it will evolve with the AI Act from the European Union. But in
Mhm.
general, in the end, it's just a tool that uses your data to build something new. And if you, in the end, you also have to store your data somewhere. And even in Europe, it's still allowed to, for example, store your data in the cloud, right?
Mhm.
And this is also someone else's computer, right? So yeah, I'm of course not an expert what all these laws belongs, but yeah, in general, there are many tools companies are using that have access to privacy related data, right? Also, if yeah, many companies have like marketing departments, also they are using maybe some tools um, that is also using a lot of privacy related data, right? Personal email addresses, names, maybe addresses, even addresses. So yeah, of course, it's um, yeah, a bit yeah, difficult, but yeah, in the end, other tools are also doing it, and it would be even possible to use Flow.BI on yeah, on-premise resources. Not sure if that is planned yet. Currently, there's only a cloud-based version, but yeah.
Mhm. Okay. And I'm guessing because of the way that AI works and the pattern recognition that's built into it, it's got to be a really handy tool for picking up things like areas that might need cleaning, inconsistent data patterns, for example, or outliers. Is that something that's sort of really deliberate with the build of something like Flow.BI, knowing that this is a tool that could save a lot of time, instead of manually going through data sets and finding these things?
Yeah, so currently Flow.BI is not able to or yeah, doesn't focus on handling like inconsistencies in the data, correcting data, or even implementing business rules. So it only focuses on the raw world and
Hmm.
only also on the model. So it also does not yeah, actually build this model that it generates, because there's also a reason for it. We have already a lot of data warehouse automation tools, um, like DBT or Data Vault Builder or other tools, and they are really good in what they do. So Flow.BI focuses on building the model, and
Hmm.
then auto can yeah, automatically via some APIs export it, for example, to DBT or Data Vault Builder, which then builds the actual data warehouse based on this model. Yeah.
Okay. Um, is Are we running the risk of losing the art of data modeling if we're leaving it to AI?
Um, I would say no, because it yeah, at first it only generates the raw world, so you still have to work in the business world.
Hmm.
That's the first point. So and I would say, in based on my experience, I would say building and implementing business rules in the business world and using building up the business world is normally more work than in the raw world. Of course, this is the general foundation and it's very important, but it's very pattern based. Yeah, so everything is defined in the raw world and relatively clear. And but I would say even if you use a tool like Flow.BI, you still have to know how data world works and you need an understanding of data world. But especially when it comes to very big source systems with thousands or 10,000s of tables, it's just a lot of repetitive work to build a big model based on so many tables. And this is the point where Flow.BI can help very good.
Any predictions for the future or something like this? Like, are we going to be at a point where we can say, here is your organization, this is what the model is that we want to use, go to it, AI, and make them do everything?
Um, Yeah, so I mean, Flow.BI is consistently improved and developed, and more and more features are coming in. I'm not sure if I can say any specific feature that will come in the future, but I would say the focus at the beginning is a bit more on supporting more source systems, and also more general sources, like not a specific source system, but more like a general data lake.
Hmm.
So this AI can then go into the data lake and there can be any data from any source system you can imagine, and it is able to model based on this data. Yeah.
Okay. One last question for you. Do you think that there's a bit of fear-mongering out there about AI in general because it's new, and new stuff always scares people? Do we need to be scared? And what sort of advice would you give to people who are a little bit wary of it?
So, I personally, I'm not scared at all about AI. I also hear it about from a lot of other people, but as long as you know how AI, at least on just a basic level, if you know how it works, it's yeah, you can use it and improve a lot on by using AI. And I don't think AI will replace many jobs. I mean, there are just new jobs and new opportunities coming, and maybe some jobs are getting way more efficient. But I don't think there are like mass firings because everyone replaces their employees with AI. I don't think that will happen. I mean, I don't know how many years ago, but when for example, in the car industry, when they started in the car manufacturing using robots, also everyone was saying, okay, everyone in the car industry will lose their jobs, and also of course, jobs change, and this will always happen with or without AI. And but I think it's important to be up to date, and also to be open in using AI, because in my opinion it can help a lot. It can improve your processes a lot, and
Fantastic. I think that's all my questions. I've learned heaps today, so thank you very much for that. Is there somewhere that people can hunt you down if they want to connect?
Sorry, the last word was?
Is there somewhere people can hunt you down if they want to connect? Somewhere like LinkedIn? Do you have like
Yeah,
a
sure.
LinkedIn
Yeah,
page? So,
yeah.
all right, if we let
I'm
people
on
know about
LinkedIn.
it.
Yeah, I'm on LinkedIn with just my name, Ole Bause. You can connect, and also if you want to talk about AI and specific tools, and
Fantastic. Thank you very much, Ola. It's been
thank you,
very educational.
thank you very much.
Hey, thanks for checking out this week's episode of the Data Radio Show. And I want to thank Ola again for sitting down and going through the basics with me. I think it's a really fantastic tool for people who might just be starting out in the industry or looking at it as a possible career option, just to get a bit of a groundwork as to what some of these terms mean and how they can impact the work that you might be doing a little bit further down the line. As I said at the start, don't forget to like, share, subscribe, tell everybody about what's going on. And until next time, live long and prosper. May the force be with you, and I'll catch you guys all next week.